This is a video about center of gravity, and it relates to Young and Freedman's University Physics Chapter 11, Section 2. It's a short section and hopefully a short video. So remember the idea of the center of mass back in Chapter 8 of Young and Freedman, or wherever, in whatever textbook you were using. The idea of center of mass is the idea if you could take a certain mass and kind of recombobulate it into a single point, where would that point be? In other words, where is the focus of that mass, no matter how it is figured or no matter what the mass is? If you could basically recombobulate it into a point, where would the point be? That point where, for all intents and purposes, if you consider all the mass to be concentrated in that space, all the equations are going to pretty much work out okay. Well, that was center of mass. And that works in outer space. What if you are talking about something under the force of gravity somewhere? Basically, and Young and Freedman don't go beyond this scenario, if the force of gravity on that object is more or less the same at all the points on the body, then we can pretty much say that the center of gravity is identical to the center of mass. There's a lovely picture on the one of the pages where they're talking about center of gravity, where they show a very large tower somewhere. Huge. I think it's like almost a quarter of a mile high, this building. And they point out that the center of gravity is only 2 centimeters below the center of mass on that very large building. So for all intents and purposes, almost any kind of object that you're going to be talking about, we're going to pretty much be able to equate the center of gravity with the center of mass, because it would have to stretch into outer space or something for us to have a significant difference between where the center of the mass was and where the center of gravity, remembering that gravity is a force of weight on something, on a mass. Okay, so the equation that we had back in 8.5 also works here. So we're going to be able to find we find the center of mass, and he proves it, by the way, in this section. He just stated it in 8.5, but now he proves this equation for the center of mass. Basically, the distance from any point to the center of mass is going to be, if you add up all of the individual masses and distances, and then divide it by the total mass, and that's going to give you the center of mass. There's a lovely problem in this section where he tries to figure out if you have a plank on a sawhorse, how much weight can you have at the end of the plank before it tips? Figuring that the center of mass, in order for it not to tip, the center of gravity is going to have to be right over, say, this sawhorse if the guy's standing here, or this sawhorse if the guy's standing over here. Using this equation, he calculates how much weight can go on either ends without the thing flipping. So, center of gravity, center of mass. Probably from a practical standpoint, because we've had chapters now on torque, on spinning force, and gravity can cause torque. This is a poorly drawn truck, believe it or not. That's what I was going for here, and I doubt that the center of gravity is where that point that I've drawn here. But basically, how do you know when a truck on an incline, or a car on an incline, or something on an incline, how do you know when it's going to flip? Well, basically, if the center of gravity, if you go straight down, if the center of gravity is outside the area of support, then it's going to fall over. So this truck, if the center of gravity is really at that point, this truck is doomed. It's going to tip over. However, if the center of gravity had come down somewhere in between the wheels, this is what we mean by area of support. If the center of gravity was here, and it comes straight down, then it's not going to flip because its center of gravity is inside the area of its support. But if the center, let's say it's very top heavy for whatever reason, let's say that all the weight is concentrated in the top of the truck, then if this is true, the center of gravity falls outside the area of support, this truck's doomed. It's going to tip over. So that's all there is in this section on center of gravity. It's basically the center of mass 2.0. And this is a short video. We like those.